Uh-oh. That's not the screen I want.
There he is. There he is.
Wow.
Anderson, you're 2 minutes early.
Really?
For 8:10 class. Yeah. Pretty impressive.
Look at that.
Sam out. Sam is late, however.
Huh.
Imagine being that way like
All right, guys. So what did y'all think of derivatives? You feel okay so far?
Yeah.
Okay. Yesterday was probably the easiest of the days as far as derivatives go. But again, if you stay with me, they're not bad. You just got to stay with me. Make sure you ask a question. I know that some of you are averse to that. Nudge a friend, let them speak for you. But make sure that you feel good about this after the chain rule. This is a really critical day. Okay, so the chain rule, even though I'm going to show it to you in a second, it's basically about composite functions. Okay? If you noticed yesterday, everything we did, the powers, all that stuff, there was a single x with that power. All right, but a composite function is a function on top of a function. Now, I don't know if you remember me saying this. Do you remember yesterday I said, what if you had something like 3x to the fourth? Do you remember me saying that the first thing you do when you take a derivative is you look at this power? And the reason I'm looking at the power is the outermost function, okay? The x on the inside is like the innermost function. So what I'm really looking at is I'm dealing with the power by going 12, drop the x to the third. That takes care of the power function. Do you remember me saying, and then go back and take the derivative of the x? But what is the derivative of x? Like if I just had an x sitting by itself and said, what's the derivative of x? You'd say 1, right? Right? Well, that's why I don't bother with that, because times 1 doesn't do anything. But what if the part that has the power is not a single number? What if the part that has the power is another function? Are you seeing that? So this time, I'm not saying 2 blah to the fourth. I'm not saying 2x to the fourth. I'm saying 2 another complete function to the fourth. Well, the way you go about this is what we call the chain rule. The chain rule says, first look at what is the outermost function. And the outermost function is that fourth power. So you're going to deal with the power rule first, and you're just going to drop the 3x squared minus 5x down the same way you would drop that x down. So look at this function and look at this function. Do you see that all I've really done is replace the x with a new function? And over here, like we did yesterday, you would have said 12, drop the x to the third. And what you didn't do yesterday is you didn't go back and take the derivative of the x part, because the derivative of the x is 1 and it made no impact on this. But today, you're going to do the same thing, but you are going to take the derivative of the inside part because it does have an impact. So the way I like to think about these is when you have that innermost function, think of it as kind of like, I always say blah. Think of it as having 3 blah to the fourth. This was a 3 blah to the fourth. But when I completed my part, the derivative of the blah was 1, so I didn't have to worry about it. But check this out. 3 blah to the fourth, the derivative will be outer function, 4 times 3 is 12, copy the blah part down, decrease the power by 1. And what that does is that takes care of the outer function. But then you have to go back to the inner function and take the derivative of it. And what is the derivative of 4x squared minus 5x? 8x minus 5. You multiply the 8x minus 5 on the outside. Are y'all seeing that? That's the chain rule. It's called the chain rule because you're linking all of these parts together with multiplication. All right, so the chain rule is basically when you have a composite function. You don't look at this and probably think of a composite function. But if you really think about it, check it out. Isn't this kind of like me saying, hey, if g of x is 2x to the fourth, but f of x is 3x squared minus 5x, then what is g of f of x? What would you do in this case? You take the f and you plug that whole thing in there, wouldn't you? And you would get 2 blah minus 5x to the fourth. So these are composite functions when you have kind of a function inside of a function. And the chain rule is required for that. You can't just do the power rule and forget about that junk on the inside. You have to take into effect this. Take into consideration that. And again, the way you consider it is you deal with the power on the outside, which will give you 8 blah, decrease it by 1, and then you go back. Once that power is dealt with, you go back and take the derivative of the inside part, which is the f of x part. So literally, you're going one at a time. I'm taking the derivative of the g, the outside part. That gives you your first step. And then I'm going to hit times, and I'm going to take the derivative of the inside part, which gives me that last 6x minus 5. And that takes the derivative of the inside part. And you might, right now, all we're dealing with are like polynomials, okay, or polynomial kind of expressions. You're going to see this chain rule shows up not just with the power rule, it shows up with anything. Like if I had a function like this that said, hey, the natural log of 3x minus 4. Well, this is a composite function. This is a linear function inserted into a natural log function. So what is the outermost function here? It's the natural log. So you will go take the derivative of the natural log of blah and just copy the blah down. Then once you do that, you go back and you multiply by the derivative of the innermost part. You don't know the rule for that just yet, but you will in a moment. Are y'all seeing this? And remember, all these rules I'm giving you, somebody came up with these rules using that ugly limit definition. And you saw how bad that was just for simple polynomials, all the math it required. Well, it's even uglier to prove it for sines and natural logs. We're not going to get into all that proof on these. I got to be honest with you, I don't even remember some of them. I'd have to go back and play around or research it. I do remember how to do all the trig functions, but they're still pretty ugly. I'll show you when we get to trig after the first test. But we're not going to worry about the proofs of all that. We'll leave that to a proof class if you ever have to take one of those in college for some reason. So I want to show you these. We're going to do some practice on them if you want to jump down here to 1 and 2. So this is right here. I'm going ahead and did this one for you, but just to show you again, this is a function of 2 times a polynomial to a power. Now again, we said yesterday, 2 things you can do with that constant. You can multiply it by the power, or if you want, you can just drop the 2 down like this. Just drop the 2 and ignore it from here on out, and then just deal with the power rule and go 3 blah squared. Either way, you're going to get 6. But the point is, on this first part, when I go 3, copy it down, squared, that is you dealing with the power. And now you've dealt with it. That's this first step right here. Then you go to the inner part, and you take the derivative of this, 20x plus 9, and you multiply it on the outside. And I don't have to have it in brackets. I used to put it in brackets when I was showing the chain part, the derivative part, but whatever. It's just parentheses, brackets, same deal. So help me out with this one. I changed the variable, but who cares? What would the derivative of f be on this problem? Help me out. So 12, so you're dealing with the power first because it's the outer function. That's 12, and what do you put in the inside? Just copy it down. That's just like you dropping the x from yesterday and then decrease that by 3. And in doing that, what did you just deal with? You just dealt with the outer function, which was the power. And by the way, the constant is not really a function. You just drop that down, right? That's here with before. Now, what's left? The inner part of the function. So you're going to go multiply and take the derivative of that, which was 8s minus 20s cubed. And that deals with the inner part of the function. And if you had 3 parts, what if you had a sine of a power? Of a function to a power. Well, you'd say, well, what's the outermost function? You'd start with the sine function. And you'll learn that derivative of sine is cosine, and you write cosine of the whole thing, and that takes care of the sine. Then you go to the power, and you do the power rule, and that takes care of the power. And then you go to the inside part, take the derivative of that. And you might have all kinds of things multiplied together. Sometimes these derivatives are huge. Okay, I used to give these bonus questions. I don't do it anymore just because it became hard to grade, honestly, and my eyes started getting fit. But I used to say, if you can write the derivative in one line, then I'll give you extra. If you're correct, I'll give you points, and if you can squeeze it into one line, I'll give you extra bonus points. So I had people like sharpening their pencils and they would just write super small and try to squeeze the derivative in there. I couldn't even read it anymore without like my old man readers on. But yeah, some of these derivatives really take a lot of space. So if you're writing them out and you run out of room, just put a plus or a minus or a times or whatever was going on and come over there and finish it up underneath, because occasionally that will happen. Now, I've tried to eliminate some of those, but just so I don't, it's just pointless to make it so brutal. Like I used to do that before I taught calculus and realized that was just wasting time. But it was kind of a game we played. But anyway, so I've tried to shorten them up, but for those of you who write really big, sometimes you may run out of room on a worksheet or something. Just finish it up underneath. All right, take another look at one of these. What do we got here before we jump to something else? So the derivative of h with respect to r would be what? So 5 times 4, that's the outer function. Now, again, you could think about it as just drop the 4 and then go 5 times 4 times the front, copy this junk down, decrease the 5 by 1. And what did you just take care of? The power. And obviously you drop the 4 down, so you don't have to worry about that anymore. So that's the outer function derivative. Then you go to the inner, and what do you have? 12r cubed minus 7. And that takes care of the inner part. And that's the chain rule. Okay, now sometimes the chain rule gets a little weird. What do you got going on in number 4? You got a quotient rule and a power, right? Now, what's the outermost function? The power? So start with the power and just treat this like a big blah. So starting with this, if I said f prime of x, what would I do? 3 blah squared, and you would just copy this fraction down. And that takes care of the power. Now what? Times, now what are you doing? A quotient rule, right? Lodi, how much I love? So quotient rule, so divide times a fraction, low, d high, minus high, d low, over low, squared. Now, if you are any like most of my classes, there's someone or more than someone in here that goes, well, could I rewrite this as 2x minus 3 cubed over x plus 2 cubed? Is that possible for me to do that? Well, yeah, your rules allow you to do that, right? And if I do that, what is the outermost function? When I say outermost, I mean, what function is involving everything now? The quotient rule. And the innermost functions are little power rules. So if you were to rewrite it like this, I'll show you, I wouldn't. I mean, this is not a big deal. But if you were to rewrite it like this, now you really don't have, I mean, the outer function is not the power, it's the quotient. So you would start with the quotient by going, all right, big fraction, you're going to have low. And then what's the d high? Oh, yeah, what's the derivative of the high? 3 blah to the second times the derivative of the inside part. Do you see that? So low, d high. And I had to do the chain rule on the top part. 3 blah 2 times the derivative of the blah. If you go to Helmer's, he didn't say blah, he says stuff. He'll go 3 stuff 2, derivative of the stuff. I just say blah. And don't say either when you go to college. Okay, don't get up in front of the class and go, you know, you just 3 blah the 2. Don't do that. Okay, so low d high minus high times the d low. How do I do the d low? That's another chain rule, right? So you're going to have to go 3 blah squared times the derivative of the blah, which in this case is just a 1. Are y'all seeing this? Low d high minus high d low over the low squared. What happens when I square a cube? Y'all seeing that? I kind of like the first way, but every year I have somebody do this. Multiple people do this for some reason. So your answers aren't going to match mine if you do it this way, because I do exactly how the problem is written. I take the derivative of it in that form. But if you simplify this and simplify mine, it means the same thing. It just looks a little different right now. Okay, so check out, I tell you what, number 5 is just like what we just did. So I'm going to go back up to the top. Now, these are some special derivatives I want to talk about. And they are the exponential functions and the log functions. Okay? So let's check out these exponential functions. And I'm going to show you the rule. And by the way, these rules aren't going to make any sense because I have not proved them. But trust me, there is a proof to why the derivative of an e to the power is what it is. Now, the reason why I chose to put a u in there is because you are probably not going to see just e to the u. You're going to see something like e to the 2x minus 3, e to the 5x squared minus 6x. So when you're doing a derivative of an e to the u, what does it look like I'm doing right here? What does that part look like I did? Just what? Copied the problem again. So the derivative of an e to a power, literally the derivative part, is just copy it down. And that is the rule. Just copy it down for taking care of the e part of the function. And by the way, you can't use a power rule on these. The power rule works when you have an x to a number, not a number to an x. And exponential functions are numbers to an x. So if I have something like this, it's important that you get that, which most people do, as opposed to something like this. Here, x to a power rule, 3x squared. Here, 3 to an x, you got to use these rules that we're going to be talking about up here. Okay, so make sure you don't go x3 to the x minus 1. It just doesn't work. And again, your question might be why. You would have to go back and look at the proofs to these to really see the why. So just trust me, we are not going to worry about the why right here because that's really beyond the scope of this class. We want to know the how. So the first thing I do is deal with the e to the u, which is just copy it down. And then I go take the derivative of whatever my exponent is. That's it. So you jump down to number 8. If you're looking at number 8, for me to take the derivative of number 8, I just copy down whatever I see. So e to the 2x cubed minus 4x. And when I do that, what part of the derivative did I just, or the function did I just take the derivative of? The e part. So I'm done with that. And then the chain rule says, go back and now and take the derivative of the u part, which is the exponent. Put it in parentheses, 6x squared minus 4. And that takes care of that part. Now, technically, what you don't see here, because you don't need to see it, is actually the derivative of e to a power is really this. E to the power times the natural log of the base, e. That's technically the derivative. And then, so that's the e part, and then you go back and go times 6x squared minus 4. But why don't I have to do that? Because the ln of e is 1. So on the e part, I will never actually write that because that is just equal to 1. And that's why on my rule for right here for e, you don't see it. Now, if it's not e, and it's 2 or 5 or 10, ln of 2 or ln of 5 or ln of 10 doesn't go away, does it? So if I ever have like a base, anything other than e, 2, 3, 5, you're going to copy it down, but you're going to go ln of whatever that base is. And that, I don't know why I put the dx there. It doesn't really matter. You can put them in any order because you're just multiplying. And then I go back and take the derivative of the exponent. Y'all seeing that? So in AP Calculus, you will never have to manually take a derivative where the base is anything other than just e. But in regular calculus in college, you do. So I don't know about Helmer's. I always teach both. And then when it gets to AP review, like we're doing right now, all I'll test them on is base e. Unless it's a calculator problem, and your calculator does derivatives. We'll talk about that a little bit later. It won't let you do the equation, but it'll give you the value at any particular point. So it can spit that out for you, which is kind of nice. All right? So that's what you do on these. And then if you jump to number 14. Check out number 14. You'll see this. So, to take, not 14, number 16. If I'm looking at number 16 and I want to take the derivative, this would be what I do. First thing I would do is go, okay, I'm going to, it's an exponential function. To take the derivative of the exponential part, I'm just going to copy this down, including the constant. Everything just gets copied down. And then I go times the natural log of the base, which is 3. And that takes care of the exponential part. And again, I don't have to do it when it's e because ln e is 1. Then what do I do for the final part of the chain rule? Take the derivative of the exponent, which is 8x minus 3. And as ugly as that looks, that is the equation you would use to find the slope of this curve at any particular point. Y'all with me? And again, you won't be asked to do this on an AP Cal test with anything other than base E, so you won't have to remember that part. I'm going to tell you right now, I will ask you on your test one of these, and I'll ask you a log that's not base E also, that's not an ln. That's another thing you don't have to do on the AP. But I'm going to test you on your test. It's going to be one of these and one of these. You'll see them. They'll probably be side by side just to make sure you know that rule. So if you go to college and you retake Cal 1, hopefully you'll all pass it, not need to, but if you retake Cal 1, you'll be ready for that. It won't be something new to you. All right, so that's the natural log rule. That's the E rule. Let's check out natural log. So I want you to look first at the function ln right there on the top right and tell me what does it look like I'm doing to go from here, which is the function, to here, which is the way I write my derivative. What does it look like I did? Just look at it, tell me. In your own words. What's on the bottom? How would you describe what's on the bottom? Whatever you're logging, right? That function that's on the inside, whatever you're logging, you just take that and put it on the denominator. And then what does it look like I did in the numerator? I took the derivative of whatever I just wrote down on the bottom and put that on the top. What happens to the natural log? Just gone. And again, why? You would have to see that in the proof with the f of x plus h minus f of x over h. You would see that in the proof. It'll simplify out that way and result this way. That is literally all you do. Okay? So if I have something like this, f of x equals 2 ln of 4x squared minus 5x. Okay? What do we do with constants? What do we do with constants? Just drop them down, right? I don't have a power to multiply by it, right? So I might as well just drop it down. So I'm just going to bring that 2 down, okay? And I don't have to look at it anymore. Now, what's the rule for natural log? What did we just say the rule was?
Derivative of x.
The derivative of what you're logging over whatever you're logging. So I'm going to put whatever I'm logging, which is this stuff, I'm putting it on the bottom. That's the u part. See, it just goes to the bottom. And then what do? The derivative, whatever's on the bottom, goes on the top. So what goes on the top? 8x minus 5. Now, if you were taking an AP test, this is a multiple choice question, you're not going to see that. What do you think you're going to see? You got a guess? 16x minus 10 over that, because they're going to simplify it a little bit. That's the only thing. So if you want to just put the 2 on the top as opposed to out to the side, probably look a little better. But again, I don't need you to simplify anything right now. That's all we're doing. Okay? All right. Now, that's for natural log. There's one small difference if it's not a natural log, and it's similar to the exponential step. If it's not a natural log, look at this and tell me, what are you seeing? What does it look like I did? And compare it to this. Here, I put the u on the bottom, took the derivative on the top. Here, looks like I put the x on the bottom, took the derivative of x on the top. So what's the difference? This has an ln of what? What's the a mean? The base of the log? Well, this also has an ln of a base of a log, which is what in this case? And why didn't I write that? Because the natural log of e is 1. So I don't have to bother. But here, the natural log of the a isn't going to be 1 unless it's natural log. So here I have to remember. So I remember on the exponential ones, remember to multiply by a ln of the base. On the log ones, remember to divide by a ln of the base. And that's only the case when the base is not e. Y'all seen that? So let's go try a couple of these. All right, so here we go at number 6. Natural log of 3x squared minus 2x. Have we done this? No, okay. So number 6, if I'm taking the derivative of this, what is my natural log rule? Drop the constant, which there isn't one. What goes in the denominator?
Just what you're.
Whatever I'm logging. And by the way, if you're really thinking in terms of chain rule, if I put a 1 on the top, that takes care of the ln. That is literally what you do for the ln. And then the chain rule says to multiply by what? The derivative of the inside part, which is 6x minus 2. I just don't like writing it like that. It looks very unsimplified. So since I'm multiplying, I just slide that 6x minus 2 on the top. But just so you know, I'm really doing the chain rule. The natural log part says 1 over the u. The chain rule part says times the derivative of that. And technically, there's an ln of e on the bottom. But do I need to put ln of e? No, because ln of e is 1. What if I had number 13? What are you going to do on number 13? For the derivative, what are you going to do with that 3? Drop it down. What do you do for a natural log of blah? And then I'm going to show you a shortcut that will save you some pain and suffering. So the rule is put the blah, so I'm logging all of this stuff. I'm going to copy that to the bottom. And that takes care of the natural log part. Then what do I have to do? See, actually the chain rule involves 3 things here, doesn't it? You got the natural log first, then you've got this power, then you've got the inside part. So what I have done right here is the natural log part. Okay, then what do I have to deal with? The derivative of this, which is the power part times the derivative of the inside. So at this point, I've got to go 6 blah to the 5th, which takes care of my 6, and then what? Are y'all seeing that? And if I didn't write it nice and compact like this, this is what it would look like. I'll give you a second to copy that down for those of you who are doing it. This is what it would look like if I really wrote it as a chain rule. Okay, so if I was really writing it as a chain rule, it would be, all right, that's the derivative of the natural log part, times. Then I go to the 6. 6 blah to the 5th, that's the derivative of the 6th part, and then times the derivative of the polynomial on the inside, 24x cubed minus 9x squared plus 2. You see that? Natural log part, power part, inside polynomial part. A big composite function linked together with multiplication. It's a big chain rule problem. But what I normally don't think that way. I go copy this, drop the 3 and copy it to the bottom, and then derivative of the bottom, which is that big thing right here, and I put that on the top. Makes it nice and simple and compact. Are y'all seeing this? Now, let me show you something. What would happen if I simplified this right now? Does anything cancel? Like, talk to me. What cancels out?
You'd only have one left, one of those.
So 5 of those with 5 of these would just leave me 1 of these left, right? And if I only had 1 left, if you simplified this, what would you really have?
18.
So the 6 and the 3 would be 18. And then that part on the top, let me show you a little trick that's going to save you a little bit of math. Don't you have a log rule that says you can swing that 6 to the front? Not a derivative rule, but just a log rule. So if you wanted to, you have the right to swing that 6 to the front and just make that an 18. Won't that significantly help your problem? Because now you don't have to deal with all that extra chain rule. You can drop the 18, copy this to the bottom, the derivative on the top, done. And it's a much more simplified answer, one that you would probably see that on your AP test as opposed to that other really expanded, unsimplified one. I would encourage you to always, when you're taking derivatives, if you have a power, swing it to the front before you get started. Now remember, that's a log rule. Don't go doing that here. I see that all the time, people swinging that 6 and making it a 24. That's an exponent. E's aren't logs. E is 2.7 something, right? An E function looks different than a log function. So don't do that rule on anything but logs. All right, what about this one? It's slightly different because it's not ln or log base E, it's log base 4. So help me out. What can I do immediately before to kind of help me out? Swing that 2. Okay, it looks better already. Now, what would the derivative be? What do? Drop the 2 down, so 2 times. So what is your log rule? To take the derivative of the log part, you do what? So I'm going to put that on the bottom, right? And then what do I have to remember to do when it's not base E? ln of the base, which is 4. Now, technically, what I just wrote right there, 2 over this, that's the derivative of the log base 4 part. Chain rule then says to multiply, right, by that derivative of that. But since I'm going to multiply, I'm just going to slide it over to the top, 3x squared minus 5. So 2 times that over that. Have we done 16?
Yeah.
Yes? Are there any on this page that we didn't do? I think there were a couple. Okay, look at, I don't think we did 7. All right, let's check out number 7. It shouldn't be too bad after all of this. This just goes back to a power rule, right? So what would the derivative of big F of t be? Help me out. So the outer function is -3. So -3 blah to the -4, and that takes the derivative of the power. Chain says then multiply by the derivative of the inside part, which would give you 2t plus 3. Not too bad. And then I wanted to show you this number 9. What's going on in number 9 when you initially look at it? What do you see? A product like yesterday? Remember yesterday I said, I said resist the temptation to FOIL these out? This would be really tough. You can't FOIL them unless you raise that to the 3rd power, right? Nobody wants any part of that. That's just a big mess. I mean, it's doable, but it's a big mess. So what I'm going to do is just look at this as a product. So this thing times this thing is what the function is, but this thing has a power on it. So when I get to taking the derivative of the first, what am I going to have to do? The chain rule, because it's got a power and a function. So check it out. First, that's this part right here. D second, that's that part right there. Pretty easy. Then second, that's this part right here, times d first. So when you get to the d first, the whole derivative of the first, you've got a chain rule. So you start with 3 blah 2. There's your 3 blah 2, which takes care of that part of the first. And then the derivative of the inside part, chained at the end, linked up at the end. You seeing that? First d second plus second, and then this whole part is a d first. And if you're wondering why I put it in brackets, it's really not necessary for me to do that since this is all multiplication, but I'm grouping these so you can kind of see what's going on here. All right, so check out number 10. It's going to stretch out a little bit. On number 10, clearly I don't want to raise that to the third, raise that to the fifth, and then FOIL it. That would take me a while. So help me out with my derivative of g. So what do you see going on here? A big, what? Yeah, product is putting everything together, and then each part has a chain rule because you have a power and a function. So here we go. First, 3x cubed minus 2x minus 7 cubed times, for the d second, help me out. Seriously, help me out. 5 blah to the fourth times 8x. So that's the d second. So first d second, and now plus second, and then I'm now here looking at the d first. How do I do the d first? A big chain, so 3x cubed minus 2x minus 7 squared. That takes care of the power, times 9x squared minus 2, end it. First d second plus second d first. And that's the kind of problem, if I don't leave you enough space, you might run into the edge of your paper. If that's the case, like say this was the edge of your paper right here, just put a times and then put that part over here under it, and then just like say times and then bring that part and finish it up. And I'll know what you're talking about, should you happen to run out of paper. And that usually happens for people who write kind of big letters. But I'll see it. I'm used to seeing that kind of stuff. What about this? Fourth root. Now, I told you don't have to bother learning a trick to that. So what do you have to do to be able to do this? Change it to a 1/4 power. So I'm going to put parentheses around this and put a 1/4 there. Kind of rewrite it. So what would be derivative of f of x? The derivative of f of x would be what? 1/4 blah to the negative 3/4. And what did you just take care of? The power. Then you go back and go times 3x squared minus 4x. And that takes care of the inside part. You did a chain rule. And I don't think I have one on here like this, but I want to show you one. So just kind of out here to the side, this is what I need you to have memorized. If I give you something like this, say a square root of 5x squared minus 6x plus 1. What did I say yesterday was the rule for square roots? If you have a square root of something, I know I said it. What do? Rather than rewrite it as a 1/2 power and do it, where it's going to be ugly looking, because that's ugly looking right there, I am going to double the whole thing on the bottom. That's the rule. Double it on the bottom. And then all you have to do to complete the chain rule is then go and finish it off and take the derivative of the inside part on the top. So literally for this, now I do have a constant, So I am going to just drop my constant down. But the rule for a square root is double the entire thing on the bottom. Literally, and you're done with the square root part. That's it. And then the chain part, normally I would just put the 1 on top if it was just a single x. But because the chain is there, I have to multiply by a 10x minus 6. But rather than do it that, I take the derivative of that and put that on the top. Because that's the chain part. That would be next. I just put it up top. Kind of like I do with natural logs. Now you can't do that on a 4th root. You can't multiply it by 4 on the bottom and then take the derivative on the top, or you're missing something. So to me, it's worth knowing this rule. It makes it very easy now if I say, what's f prime of 2? You tell me. Look at this over here. Look at that. If I said now, find f prime of 2, and you plug a 2 in there, then you have to raise it to the negative 3/4 power. So you have to think about, okay, I got to take the 4th root, then cube it, then flip it. It's already ready to go here. If I say find f prime of 2, you're just plugging a 2 in. It's nice and simple. Trust me, you are going to want this rule. Drop a constant, double that on the bottom, derivative of the inside part on the top, and you have knocked out all facets of that square root. And you'll be glad you know that trick as you move through calculus. Y'all with me? Okay, be prepared for me to ugly it up a little bit. But if you get this part, you are home free with derivatives. So make sure you check your work so that you're catching any small errors, like forgetting to put parentheses around stuff, that kind of thing. And if you see me not using my little square root rule, and I'm doing it the ugly way, tell me. I think I've fixed all those. I used to do that in the olden days. But bad. Oh, by the way, I don't have time to hand them back right now.